Hey everyone! Recently, we were shown Galapagos, which is a film about evolution, a biodiversity aspect. In relation to biodiversity, we will talk about how innovations in the domain of the Internet of Things will influence scientific explorations and biodiversity-related researches. So a bit about the Internet of Things is that it is a set of products, services, and processes that virtualize the real-world things for digital processing. Basically, a digital representation of the world interacting with digital systems and applications.
The Internet of Things, a virtually connected network of physical devices such as lab equipment and sensors, can help solve problems that researchers have traditionally addressed over hours or days of direct monitoring. In addition to collecting data about equipment performance in laboratory conditions, scientists can use the Internet of Things to deposit vast amounts of experimental data into the cloud directly from instruments and to control experiments remotely.
Technology has expanded and has also been continually utilized for our convenience. Science, included, has received a lot of benefits by employing the help of technology, increasing complex research questions and global challenges. For example, climate change and biodiversity are driving rapid development, refinement, and uses of technology in ecology. This trend, this trend created a distinct subdiscipline termed as techno-ecology.
So there's this innovation called ZebraNet that allows peer-to-peer networking transfer of data through the help of Internet of Things. The way it operates is that they create a smart environment so wildlife researchers, or researchers in general, can track or map wildlife identifications. So they place their acoustic sensors or smart cameras in areas that are difficult to access. Unmanned aerial vehicles, or UAVs, equipped with Internet of Things, can wirelessly get data from these sensors in the area and transmit it to the observing researchers in another area. With the ability to collect vast quantities of high-resolution spatial and temporal data via permanent and perpetual environmental data recording technologies, the development of methods to manage and analyze the data collected has become more pertinent. Sensors and monitoring microchips are also attached to animals or landmarks or bodies of water to better help scientists relay data about air pollution, nuclear radiation leaks, floodwaters, and E. coli outbreaks. Sensors can be attached to birds, for example, to examine aerial pollution like reading the amount of carbon concentration and whatsoever. There are also color nodes fitted in terrestrial animals for more technological real-time relay with the help of Internet of Things.
Technologies to identify individual animals, follow their movements, identify and locate animal and plant species, and assess the status of their habitats have become better, faster, and cheaper as threats to the survival of species are increasing. This collaboration of science and technology has paved new creative approaches for more non-invasive and convenient alternatives to help conservatives and researchers to discover and mitigate our world's ecology. The Internet of Things has provided us with better avenues to track what's wrong with our environment so we could create remedies before it all falls in vain.